Howdy. Let's take a quick look at this landscape here. It is a landscape I have been watching many times. I have been making videos about this. It is very interesting. It's a fractal pattern, Lichtenberg figures. Wherever you look. And it's a rather large area. It is situated in Russia, Siberia. It is part of the Siberian Traps. Which is, amongst other, how to put it, names which are like record breaking. It is one of the world's largest basalt occurrences on Earth. And beside it, we have, in a way, the opposite of it. We have craters after craters after craters, and we have white sediments. These might be roads. These are probably oil or gas drilling operations. And no doubt they are sticking out like a sore thumb. They are really well visible. If you just go close enough. The Siberian Traps are very interesting and very important. And because I was watching the weather, I had to once again check if there's anything about the Siberian Traps, and I think I found something very interesting. The Royal Society, Philosophical Transaction of the Royal Society A, Mathematical, Physical, and Engineering Sciences. You have access. Sales and gas generation in the Siberian Traps, made some 3 years ago by many people. Abstract. On its way to the surface, the Siberian Traps magma created a complex subvolcanic plumbing system. This resulted in a large-scale sill emplacement within the Tunguska Basin and subsequent release of sediment-derived volatiles during contact metamorphism. First, they think these are all volcanoes, like, common volcanoes, as you know them, and they are assuming that this is all just lava flows. But I don't see any reason why they should be lava flows, since lava doesn't flow in dendritical patterns. Lichtenberg figures. I think they are created entirely by electric discharge events back in the past. And since they are situated rather north, it might have to do something with the Earth's north or south pole, or however you want to put it, with a pole back in the days. But let's continue a little bit reading. The distribution of sills and the released sediment stored gas volume is, however, poorly constrained. In this paper, results from a study of nearly 300 deep boreholes intersecting sills are presented. The results show that sills with thickness above 100 meters are abundant throughout the upper part of the sedimentary succession. A higher proportion of the sills was emplaced within the Cambrian evaporites, with average thicknesses in the 115 to 130 meter range and a maximum thickness of 428 meters. Thermal modeling of the cooling of the sills shows that the contact metamorphic aureoles are capable of generating 52 to 80 tons of CO2 cubic meters per square meter. Maybe square meter. I don't know. With contributions for both marine and terrestrial carbon. When upscaling these borehole results, an area of 12 to 19,000 square kilometers is required to generate 1,000 gigatons of CO2. This represents only 0.7 to 1.2% of the total area in the Tunguska Basin affected by silts, emphasizing the importance of metamorphic gas generation in the Siberian Traps. These results strengthen the hypothesis of a subvolcanic trigger and driver for the environmental perturbations during the end Permian crisis. This article is part of a discussion meeting issue hypothermals, rapid and extreme global warming in our geological past. Introduction. The emplacement of the large igneous provinces, LIPs, coincides in time with several of the most severe crises and hypothermals from the history of the Earth. Large igneous provinces, like these are the biggest, the Siberian Traps. And somehow this just reminds me of the large, low shear velocity zones, of which one plume is under the Canary Islands, one of the biggest. These are the large low shear velocity zones are lava plumes within Earth. I made videos, so you can check it out. But anyway, such as the Paleocene, Eocene thermal maximum, the Thracian, the end Triassic, and the end Permian. Maybe these are spaced somewhat 12,000 years apart from each other, maybe much more, I don't know. But anyway, it seems to be something coming in cycles, a repetitive pattern. It happened in the past, so we have to expect it will happen in the future again. Within many of the LIPs, not only there is a large outpouring of volcanics at the surface, there is also a significant subvolcanic component, with magma having intruded into sedimentary rocks as sills, dikes, and volcanic centers. Gas release directly from the igneous rock or igneous, CO2 and SO2, and at contact aureoles around intrusions such as sills, CO2, CH4, CH4, and CO2 may explain rapid global warming and other perturbations such as ozone layer destruction. Here, the Siberian Traps and the end Permian crisis are used as an example of how LIPs and environmental crises may be causally linked, with specific focus on the potential for gas generation in the metamorphic contact aureoles, in the sedimentary rocks around the subvolcanic intrusions. I think the Siberian Traps are in a way made like this. Let's imagine this would be mantle or crust. Let's just imagine this would be a hotter layer beneath. Is it lava? Is it hot water or everything together? But it's just much more hot. There might be this water layer in between as well. However thick it is, it depends on the place. And then, very simplified, a lightning strike struck, which penetrated through the mantle, made a connection to below, and during the event, maybe the stuff got pulled out of the ground and it formed the hills. Let's draw some tetrahedrons here. The other way, it could be that there has been just so much dust in the air, maybe also from other planets, Venus, Mars, and the electrical discharge just fused them into place, since they seem, at least to some degree, just being on top of the former ground. And there has been probably made connections from the grounds below to the heavens, and therefore there is a very good possibility for gases to evaporate from the ground. And since there is anyway some kind of electromagnetics involved in the whole process, the Siberian traps seem to be, let me say it just like that, charged positively. They have the same charge as the surface conductivity anomaly in Scandinavia, the Kursk magnetic anomaly. So they, in a way, rather attract high pressure systems. The Siberian Traps is one of the world's largest LIPs, with outcrops and subcrops widespread in the northwestern Siberian craton, including the Tamuir Peninsula to the north and below the West Siberian Basin to the west. The volume of igneous rocks is estimated to be a minimum of 1.7 million cubic kilometers, with the main pulse of emplacement taking place through the Tunguska Basin in East Siberia around 252 million years ago. The sills and dikes are abundant throughout the basin and form sheets up to at least 350 meters thickness, locally comprising up to 65% of the basin's stratigraphy, with a maximum cumulative sill thickness of 1,200 meters. Some examples of the thick sheet sills outcropping in coal-bearing sedimentary rocks are given in figure 2. Coal. So something got burned very badly. That's, we have coal and gas and all kinds of things. And here we have some pictures. Do they work? Yes. Since they have the shape they have, these are vertical structures within the rocks. So there has to be being vertical updraft currents of energy, which created those vertical structures. Maybe electricity. And then if you check out the Siberian Traps, let's go here somewhere. They are all approximately the same in height. They have flat tops, electrical etching process. And there is like all kinds of very, very amazing things to be found there. Tell you. Let's just check out, is there any picture? There aren't too many pictures. That's a region where it's rather hard to find, like. Let's take this one here. Yeah, I think this works very well. Haha. Check it out. Check out these rocks. They are overhanging. They are almost vertical. And here we have also these kind of triangles pointing down. They are rather black. So these were once really hot, and the whole region is very beautiful. This would be a place to go around there. Building a cottage somewhere and just stay. Here you can see somehow like what I tried to explain. It's rather flat. There's like they are not this kind of hills. They are rather this kind of hills. Electric etching. Why I talk about the Siberian Traps? Because I found a new application. wxcharts.com. And I really don't know how yet to use that application, but I think it's very interesting. It looks very nice. And obviously we are looking at the northern hemisphere, temperature at 2 meters height. Oh. And this is where we are now, I guess. This is cold, this is hot. And we can zoom in. There's like many other models, but let's check out the higher temperature geopotential anomaly. There are so many, different kinds of things. That's a very cool application. Sea surface temperature. (850 hectopascal). So this seems to be higher up. And right now, there is a colder region above Scandinavia. And also about the Siberian Traps, Siberia. And I've been watching some other models, and it seemed that the region in Russia near the Siberian Traps increases to get really cold in some time from here, which also means it's growing in size. I find it interesting here it's reaching down from the Siberian Traps, and there's this bubble which goes over Scandinavia. Over Scandinavia into Greenland. It's just this one little bubble. And it goes down to Denmark, almost reaches the British Islands. And I find it very interesting that basically, as it has been in the past, the weather should come from here and it should bring warm air to Europe. But look at this blob or this region here. It moves from east to west. And it in a way blocks the stream which is coming from the west. And here it dips even down more south, almost reaching the Canary Islands, which are here. The green, I don't know, maybe it's 0 degrees. It dips really down, really deep down. First, it's coming from this side and it's going rather deep down, and then it's coming from the other side and it's going also very deep down. This is how it should be, basically. The weather is coming from here and going there. This it has, like it has been in the past. And maybe that's just something very different. But it seems that there is this part which is like really strongly moving towards America. It's anchored in Spain and Portugal and Ireland and England. And then it just plunges up into Greenland. And there's a next one coming. And this blob here could, in a way, block the rest which is coming. There is no warm air coming here from here. Maybe there is warm air sucked up from the equator from this one special area I have been reporting on since months. And maybe I have to check it out. This stream. It's sometimes a little bit more here, but it's basically it's making a connection from there might be some islands there, yes. Braya. And this has been going on for quite a while. Sometimes it's stronger, sometimes it's less stronger. Do we get any moving picture? Yes, we get. No. But this is mainly how it basically, at least I see it. Let's just imagine this would work. This is where the weather is coming from to Europe. That's why Europe was thriving. We got warm weather. It was rainy in England, and this is how it worked. And here from the south, there were supposed to be all those cyclones going to America. I don't know, has there been any which started somewhere here and went all the way there, and they made predictions when it would hit America? I don't know. I haven't seen any like this kind of original old school hurricanes this year. There has been storms, but they all originated somewhere here and then just went there. But they didn't originate from this side, went all the way to the Gulf of Mexico. And as you can see still here, there is a rather strong flow going from the Gulf or even from this side. That's connected all the way to Europe. And if these clouds would move here, we could probably see better, but they don't show us. Let's try something else. Visible. Do they move on visible? No. Why? And also, that's very interesting, this structure here. And I think it has to do something with the surface conductivity anomaly. But my point is, the Siberian Traps, which are somewhere here, they are rather big. Where it's cold, and it's very cold, and it's also very cold here, minus 50 degrees almost. And the Kursk magnetic anomaly, which is here, and the surface conductivity anomaly. If they join each other and making one big, let's say, positive charged region, which would indicate that we would get very high pressures, a strong high pressure system, which would mean it would get very cold in a very big area from Russia to Europe. And if it really happens that this cold air is plunging here into the Atlantic, it could mean that streams like this would either turn south or north, which would be very interesting. They could turn north as well, bringing some warm air up into the north, and everything starts to melt. And you know the story. All of a sudden it flips and everything freezes over. So I was just thinking, if the ice from the Arctic, I don't know the actual sea ice extent at the moment, but if it would reach a region like that, if all that would get frozen over, no warm water or air could anymore reach more north. So is this kind of boundary layer, or whatever bow shock I called it once, is this some kind of boundary for ice? You know, this would be the point if the ice would reach that line. The whole weather in Europe would collapse in terms of very cold. I don't know. It's interesting to see. That's why the Siberian traps are so important. And maybe that's the reason why there it's so cold. Because they are attracting high pressure systems, and according, like, if you have a high pressure system in summer, the sun is shining and it's really hot because it's summer. If you have a high pressure system in winter, the sun is shining but it's very cold. You know, plus and minus, the opposite, same but different. That's why I think the Siberian traps are very important, combined with the Kursk magnetic anomaly, the surface conductivity anomaly, and all these kind of things. There is still so much work to be done about this, research and stuff. So I'm just sharing, in a way, like, things about what I think they are important that we have here in southern Sweden. There is something going on, obviously. It seems to be almost spinning. And there is even lightning. Yeah, I would call this a spinning motion. Not only do we have Gothenburg here, but we have also, which seems to be quite in the middle of the whole thing, this island. Hornfiskron! Let me show you, and then I will end because that's an endless video already. Hornfiskron. Where you can find this. Now there are sheep drinking. So I assume this is fresh water. Maybe this island is also growing, like the one off the coast of the Netherlands. A growing island. Maybe there's some kind of a volcano, mud volcano. Maybe it is the reason why this stuff is spinning around this place, because there is some volcanic activity going on underneath the sea floor no one knows about, despite there being signs in the sky. So the Kursk magnetic anomaly, the Siberian traps, they might be a key understanding point of the winter weather in the northern hemisphere in Europe and Russia, because it could be, or it could get really cold. Earth's magnetosphere is weakening, the poles are on the move, and all these kind of things. But the geological imprints and certain and conductivity components of the mantle of the crust and all the kinds of circuits that we have, water lines, etc. If you have much metal or whatever sort, if you have of whatever material in the ground of which the rocks are made, if you have a huge amount of something in some place, it will affect whatever electrical currents, hence the weather. That's why the weather system get more and more stuck into places, because the actual magnetosphere is maybe weakening so much that the things in the ground in a way affect the weather more than the things above. They attract them and they keep them until there's even something bigger which pushes them away. Maybe that's a crown of some volcano which is going to wake up in some time. The crown. And here is the thing. Maybe there are many things here. We don't know. We don't see them. They don't show us. There's not too much earthquake activity going on there. Probably not even necessary. If there is like this kind of clay mass underneath the ground, it doesn't really do anything if it moves because it's soft. It's not rock. Just imagine this kind of quick clay incident in the Baltic Sea, on the sea floor, just some huge landslide all of a sudden happens. There could be tsunamis and all these kind of things. Gas emissions, SO2, CO2, or whatsoever. And if there is establishing a big or strong high pressure or low pressure system in some place, like, in a few weeks, there would be like a really massive high pressure system here, many millibars. It could affect these kind of things. The energy flow is much more than between the ground and the heavens. And as I watch this, maybe northern Italy, Switzerland, the Adria area, and many other places, Germany, they need to be warned. There could be very bad weather coming in the next few hours. But I think I leave it here, more than a half an hour of blah, 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 blah. Thanks. Bye.